Hi, my name is Archana. I've been working with Oracle since version 6. I started my career as a software developer and then moved into database administration. I've worked as a DBA for more than 15 years now. This presentation will begin with a description of the Oracle multi-tenant architecture, followed by how to create a container database and a new pluggable database. We will also view the structure of a pluggable database and watch a demo. To begin with, let us understand the multi-tenant architecture, its benefits, and how it relates to the non-CDB database. One might ask, why multi-tenant? Businesses utilize new technology to prepare for the future and increase their profitability. The multi-tenant architecture addresses the challenges which organizations are facing today. It makes consolidation and manageability easier. In a large organization, there may be thousands of databases. Each application database may also be hosted on a separate server. This increases the cost of hardware, software, and system resources. It also imposes manageability challenges with rapidly changing business needs. With improvements in hardware technology and capacity, a server is able to handle much larger workloads now. A non-CDB server may not utilize all of its resources while hosting a single database. Another non-CDB server may be heavily loaded and experiencing resource shortages. The multi-tenant approach provides an architecture which can reduce wastage of system resources and use a powerful server to host a multi-tenant database with one or more pluggable databases or PDBs. Often, a PDB may only utilize a fraction of the system capacity. As you can see in the illustration, a container database uses a multi-tenant architecture which comprises one container database and one or more pluggable databases or PDBs. A pluggable database or PDB is like a non-CDB. Administrative tasks such as backup and recovery, performance monitoring and tuning, resource management, and upgrades and migrations can be performed just like a non-CDB database. A PDB can be unplugged from one container and plugged into another container with simple commands. A CDB may also contain a set of interrelated application PDBs as an application container. The application container seed is created when the application container is created. It may have some common objects such as tables or code, which is referenced by the application PDBs which it contains. There are many challenges in a non-CDB architecture. Large organizations may use thousands of databases, each of which run on multiple platforms and physical servers. In an effort to reduce wastage and use resources efficiently, organizations may use a single server to host many databases which do not share background processes, memory, or Oracle metadata. Logical schemas and VPDs require more effort to manage, secure, and transport. A multi-tenant architecture allows you to consolidate data and code without altering existing schemas or applications. A container database can have many pluggable databases. Each pluggable database behaves like an independent non-CDB database. This allows for many benefits at the PDB level, such as flash recovery of a single PDB, performance tuning, including collecting performance metrics for a single database, and patching. It is easier to apply a patch or upgrade to one database than to many databases. Applications can have their own PDBs or an application PDB with a common application root container. Application containers can share data across its PDBs through a data-linked common object. Data can be copied quickly and migrated between servers for upgrades. An application container can be defined for a set of application-specific databases. Using the seed database of that application or that application container, Each application pluggable database can use a common set of tables, views, code, or other database objects. A container database has a CDB $root or system container. The root container contains metadata about PDBs, schemas, and schema objects. The data dictionary in a root CDB contains metadata about all containers and PDBs. However, each application container or PDB which is plugged into the root CDB have their own data dictionary with metadata information. For example, the DBA objects view shows different number of rows in each PDB. The PDB $seed is created when a container database is created. It is used to create PDBs. A standard PDB or PDB is a pluggable database which consists of schemas, users, and related objects. PDBs appear as a separate database to clients. The current container is the container in which the session is currently running. A current container may be the CDB root, application container, or a PDB. An application root is the root container for an application. The root can be used to create pluggable databases, start up and shut down PDBs, store application common objects, and is in some ways like a CDB root container. As an example, let us consider a large organization who is a SaaS vendor. Each customer of the vendor could have their own PDB with a specific customization. A common data linked object can be shared by all PDBs which have identical data for the object. An application administrator can manage the definition changes in one location so that every PDB gets the change to existing schemas automatically. The application container is like a container database. Application common objects, common users, data, metadata can be defined in the application container and shared with all the PDBs which are plugged into the application container. When upgrading or patching, the application root is patched or upgraded and all the changes are automatically propagated to all application PDBs. An application container can also contain proxy PDBs, which are PDBs in other containers. A PDB can be migrated to a higher Oracle database release by unplugging from an application root. A container database can be created during installation using Oracle Universal Installer. If you have not created the database at installation, you can start the Database Configuration Assistant or DBCA to create the database. Alternatively, you can also create a container database by issuing the Create Database SQL statement with Enable Pluggable Database clause. Oracle supports the creation of one or more CDBs in the same Oracle home or different Oracle homes on the same physical server. It is good to plan the CDB creation before starting. Estimate the amount of space required for tables and indexes of each of the pluggable databases and determine the file locations. Familiarize yourself with the initialization parameters that can be included in an initialization parameter file. You must choose a character set for the CDB and consider which time zones your CDB must support. Select a database block size for the CDB. There is a separate sysaux and system table space for the CDB root and for each PDB. Plan the temporary table space locations and sizes, determine undo table space requirements and locations to manage your undo data. Determine the database service names needed for your applications. Learn how to start and stop an instance and back up the files and logs periodically. If you plan to use Oracle RAC, then plan for an Oracle RAC environment. Let's see a demo of how to configure and create a CDB. Database Configuration Assistant, or DBCA, is strongly recommended for the creation of a CDB. If a CDB has not already been created at install time, it can be created after the installation completes using DBCA. Choose Create a Database on the Database Operations screen and click Next. Choose Advanced Configuration on the Creation Mode screen so that you can specify details. I'm selecting Deployment Type of Oracle Single Instance. Click Next. The database identification step requires a global database name and SID. Enter the database name. Check Create as Container Database checkbox. Check Use Local Undo Table Space for PDBs. While creating the container database, one may create one or more PDBs. I have only planned for a container database for one. So I will check Create an Empty Container Database and click Next. For the storage options screen, select the storage type you're using and the file location for the database files. I have accepted the defaults and check the Oracle Managed Files checkbox. Click on the Multiplex Redo Logs and Control Files to specify additional copy locations for the redo logs and control files. I'm selecting Redo 1 and Redo 2, two separate locations for my archived redo logs and control files. Let's go to the next screen. Check Enable Archiving to create the database in archive log mode. Additionally, click on the archive mode parameters to specify the location of archived redo logs. In this case, there are two archived redo log destinations. Choose an existing listener or create a new one on the network configuration screen. In this case, there's a default listener already present. Otherwise, create a new listener and specify a non-default port. Click Next. Since I am not using Oracle Database Vault or Oracle Label Security in this demo, I will proceed to the next step. Select Database Configuration Parameters in the Configuration Options tab. Enter the SGA and PGA size. Click on the other tabs to verify if your configuration requires any specific configuration. One can select maximum number of processes, Unicode, the national character set, default language, default territory, and connection mode. Click Next to go to the Management Options screen. If you would like to use Enterprise Manager, check the Configure Enterprise Manager checkbox. Select the port number you want to use. Optionally, check the Register with Enterprise Manager Cloud Control checkbox if your installation uses it to manage and monitor databases, and click Next. Specify administrative password in the User Credentials screen. It is a good practice to use different passwords for sys and system users. Confirm the password and click Next. On the Creation Options screen, check Create Database. As you can see, there's an option to save the creation steps as a template also. Click on All Initialization Parameters to view the parameters and ensure that the required values are as per requirements. Click Next. Click Finish to begin the creation of the container database now. The installation may take more than 15 minutes. When the database has been created successfully, a notification is displayed. Let's click on the Details button to see details. When the installation database has been created successfully, a notification will be displayed on the screen. As we can see, the installation is complete now. The log file name has been printed. You can look at the progress details in the details pop-up. Let's close this. And close this installation screen. A new PDB can be created using various techniques. When a PDB is created from scratch or using a seed PDB, the files associated with the seed PDB are copied to a new location and associated with the new PDB. A new PDB can be created by cloning a source PDB or a non-CDB. A new PDB can be created also by relocating a PDB from another CDB. The source files are moved to the new location. A new PDB can also be using an XML metadata file. Create a PDB as a proxy PDB by referencing it via a database link. This technique can be used on the same CDB as the proxy CDB or another CDB. In this demo, we will create a new PDB and explore the structure of a PDB. I have specified the create pluggable database statement with some clauses. A new user PDB1 ADM with the PDB DBA role is being created. In order to have control over the location of the system, temp and undo table space files, I have defined the path prefix clause. To view information about each PDB, the DBA PDB's view can be queried. As we can see, the pluggable database has now been created. Let's view the information about the PDB. The output shows that there is one seed PDB and a new PDB which has just been created. The $PDB's view can be queried to list the name and open mode of each PDB. The new PDB1 database, which was just created, is in mount mode. It needs to be in read and write mode before connections can be made to it. To change the mode of PDB1, alter pluggable database open SQL statement can be used. To check the open mode now, let's run the same query once again. The PDB1 database is in read write mode now. There is a new view, CDB_users, which contains information about users in PDBs. As can be seen in the output, the users sys, system, and other standard Oracle users exist in the new pluggable database. The new user, PDB1 ADM, has just been created in the pluggable database. The structure of a pluggable database is like a non-CDB database. The data file structure can be listed by querying the CDB_data_files view. The system, sysaux, and undo TBS1 are created automatically. Similarly, the temp table space is automatically created with the location specified. The CDB_temp_files view lists the temporary files in the new PDB1 database. When creating the pluggable database, a new user, PDB1 ADM, was created. Since a pluggable database is like a non-CDB database, the user exists only in the new pluggable database. This can be verified by taking account of the number of rows from the root container, which is CDB$root, and again from the PDB1 container. Since the number of rows in the PDB1 is one more than the CDB$root, it is because of the PDB1 ADM user, which is a local user in that database. This brings us to the end of the presentation. Please see Oracle Books online for more information. Thanks for watching.